Hi, in this new assignment, we're going to assess the repeat sprint ability and high intensity intermittent exercises on a comparative analysis of the RSI repeated sprint ability test, the yo-yo intermittent recovery 1 and yo-yo intermittent recovery 2. For sports science practitioners, my name is Mariano Saurio. Why assess intermittent capacity? Because of match demands on team sports require repeated sprints, acceleration, and high-intensity bouts with incomplete recovery. And these help you out in decision making because you can get objective data guides, team selection, physical profiling, and conditioning priorities for individual athletes. These help you in monitoring the adaptations. You can track seasonal fitness changes and responsiveness to specific training blocks like preseason, in-season, competitive, and this helps you out in the performance links so you can get strong correlations with high intensity running distances and the ability to perform repeated sprint sequences in matches. Help also helps in programming input, results in directly in form of high intense intermittent training prescriptions, repeated sprint ability training, and periodization targets. Another thing that you can get is talent identification. You discriminate between elite, sub-elite, amateur level across various positions in intermittent sports. The physiological foundations here is the energy system interplay. The ATP-PC dominates explosive efforts on 55.9%. The glycolytic power short-term work, it's around 44%. And the aerobic drives basically recovery. The PCR kinetics, you have a rapid phosphocreatine resynthesis during brief rest intervals, which is critical for maintaining sprint performances. You got the glycolytic flux, and increased glycolytic contribution in later repetition leads to lactate and hydrogen accumulation and metabolic acidosis. The aerobic contribution of the system powers recovery between bouts. Higher VO2 max correlates with reduced performance decrement. The mechanisms of fatigue, the peripheral fatigue, metabolic and ionic disturbances dominates, with central fatigue, the neural drive in severe bouts. What's the neuromuscular cost? The change of direction and braking forces significantly elevate mechanical load and neuromuscular demands. RSI test protocols and procedures. The test formats, typically protocols include 6 per 30 meters linear or 10 per 20 shuttles with 180 change of direction to replicate different sport-specific movement patterns. The work and rest ratio is a standard recovery is 20 to 30 seconds passive rest between sprints, creating a work and rest ratio of approximately 1 to 3 to 1 to 5. Timing methods. Precision timing use dual beam electronic gates to record every sprint individually, ensuring high measurements and accuracy. When you should stop, the test terminates upon failure to complete sprints within specified time limits or by positional exhaustion or stopping. The athlete says, "No more, I can't," you stop the test. Key outputs and content measures includes best, mean time, and fatigue index, contextualized by sport-specific change of direction demands. The energy system contributions in the RSI, the single sprint breakdown. For a single 6-second sprint, the ATP-PC contributes 55.9% and glycolysis around 44.1%. There's high reliance on phosphocreatine stores for maximum power. The repetition dynamics, the PCR dominates early reps as the PCR depletes because the incomplete recovery, glycolytic reliance increase in later sprints to maintain output. What's the role of the aerobic system here? It's critical during recovery intervals because it drives the PCR resynthesis and clearance of metabolic byproducts between high intensity bouts. What are the rest length effects? Short rest, less than 30 seconds, limits the PCR restoration, increasing fatigue index. Long rest allows greater PCR recovery and sustained power. Modality differences. Running RSI elicits higher overall energy demand and PCR depletion compared to the cycling RSI due to large muscle mass recruitment. The condition implications. Training must target both PCR turnover, the power, and glycolytic capacity, the tolerance, alongside aerobic base for recovery. The airside fatigue mechanisms and recovery. You have a metabolic accumulation as the PCR depletions alongside accumulation of phosphate and hydrogen. The lactate levels typically reach 9 to 15 millimoles per liter post-test. The pH and glycolysis, the intermuscular pH drops around 6.8 to 6.9, which inhibits the PFK enzyme activity and slow PCR resynthesis rates. The ionic shifts, the potassium efflux, sodium accumulation impair membranes excitability, reducing muscle fiber conduction and velocity. You have central factors that reduce voluntary activation and neural drive occurs under severe metabolic stress, which is central fatigue, and recovery and elite performance. Fast PCR resynthesis, 20 to 30 seconds, and minimal decrement, around less than 7%, are hallmarks of elite repeated sprintability. Sport-specific relevance, soccer correlations. This shows strong correlation, 0.71 to 0.77, with match play, high intensity running, and total sprint distance. What are the sprint sequences? Crucial for repeating maximal efforts during critical matches phases and under accumulated fatigue. For the indoor team sports like basketball, handball, the formats, the shuttles, align closely with game-specific change of direction patterns and court transitions. What about rugby? Backs require RSI for open field play. Forwards benefit more from repeated acceleration ability in contact zones. And it depends on positional demands. Higher relevance for wide players like soccer, and pressers who perform frequent high speed repeat bouts. The yo-yo intermittent recovery 1 protocol and scoring, the test setup and procedures, 2 per 20-meter shuttle runs back and forth, paced by audio beeps, conducted on flat non-slip surface. Progressive intensity starts at 10 km per hour, level 5, with progressive speed increments at each new stage level. You have active recovery period, mandatory 10 seconds active recovery period, 2 per 5 meters walk or jog behind the start line between each shuttle. Termination criteria, the test ends when the athlete fails to reach the finish line twice consecutively or stops voluntarily. Same in the last test. The scoring output, the primary performance measure is total distance covered in meters, including the last completed shuttle. Physiological demands, VO2 max correlation shows a strong correlation with direct VO2 max measures, serving as valid field proxy for aerobic powers. This also elicits near maximal cardiovascular strain with heart rates reaching 95 to 100% of heart rate max at the point of exhaustion. The lactate response, peak blood blood lactate concentrations typically range from 8 to 12 millimole per liter, indicating significant anaerobic contribution alongside aerobic demands. The aerobic emphasis, while intermittent, the progressive nature heavily taxes the aerobic systems to fuel repeated 40-meter bouts and limit metabolite accumulation. Also, you have to take in account the recovery capacity because the performance depends on oxidative capacity and the PCR resynthesis rates during the brief 10 seconds activity recovery intervals. And what are the training sensitivity for this test? It's highly sensitive to training status, capable of detecting small but meaningful fitness changes in both preseason and in-season phases. Normative data and benchmark. You have here the performance standard and the level of interpretation. Elite male soccer and rugby, 2400 to 2800 meters. That's international top tier pro. You have the sub elite. Here we have the ranges. You see the smallest worthwhile changes, more than 5 to 10% represents meaningful physiological adaptations beyond typical error, and the coefficient of variation retest reliability ranges from 4.9 to 8% standardized conditions strictly to minimize noise. What are the applications here? It works for HIIT prescriptions via percentage of velocity, yo-yo 1 intermittent recovery. Use final test speed of the test to prescribe individualized HIIT formats like 15-15 or 30-15 runs. In-season monitoring, track fitness fluctuations efficiently with minimal administrative load, and this allows regular checkpoints. It can also helps for benchmarking and rehab purposes, establishing benchmarks for specific roles and positions, and guide return to performance progression post-injury. GPS integration. This correlates the test results with match metrics like high-speed running, acceleration density, and change of direction load, and also helps you in load management pairing, integrating the results with RPE, heart rate recovery, and heart rate variability to optimize weekly training load management. The yo-yo intermittent recovery 2 protocol and differences. It has a shuttle format, utilizes the same 2 per 20 meters shuttle formats as the intermittent recovery 1, requiring repeat accelerations, deceleration, and 180 turns. Higher starting speed, it starts at 30 km per hour versus the 10 km on the IR1, immediately imposing a greater metabolic and mechanical load. The test progression features faster speeding increments, resulting in significantly shorter time to exhaustion compared to the other test. The active recovery maintains the standard 10 seconds active recovery between shuttles, identical to the IR1 protocol. It has an anaerobic focus. The total distance score reflects a higher anaerobic contributions suitable for assessing recovery from severe intensity. And this is for elite application. This is basically designed for elite cohorts to provide greater discrimination, slightly higher CV, but acceptable retest reliability. The anaerobic emphasis. Extreme metabolic strain. The peak blood lactate reaches from 12 to 15 millimole per liter with significant muscle pH drop to 6.6 to 6.8 at exhaustion. The dominance requires significant greater CP degradation and glycolytic turnover rate compared to the Number one protocol. This is for elite benchmarking. International elite soccer players typically achieve 760 meters, strongly differentiates between top tier levels. Performance correlations. It has a high correlation with peak of 5 minute high intensity running periods during match play. It has a highly sensitive to training status changes. Seasonal improvements often are larger than the number one, the IR number one. The target population best suited for athletes with high anaerobic intermittent demands, where recovery capacity is critical limiter. What are the applications? Elite soccer differentiation distinguishes performance at top levels, highly relevant for roles demanding intense pressing and transition actions. The rugby utility, critical for backs and utility players who perform repeated high speed efforts with limited recovery during play. Indoor, for court sports. It's a complement to the RSI testing when aerobic base is established, assessing severe intermittent capacity in dense schedules. Hockey and futsal benchmarking consider a change of direction density, adjust interpretation based on the sport specific constraint and smaller court dimensions. Also helps you out for profiling spectrum, because when you combine this with the RSI maps to complete aerobic and aerobic intermittent spectrum for precise athlete profiling, and helps you for hit prescriptions guide results, guide severe intensity interval training targets, enabling precise speed time prescription for conditioning. Comparisons between the RSI, Yo-Yo 1 and Yo-Yo 2. Here's the comparison. The primary demand on the RSI is repeated maximal sprint. Yo-Yo 1, aerobic intermittent capacity, as well as Yo-Yo 2. The duration, RSI 2 to 5 minutes. Yo-Yo 1, 6 to 20 minutes. Yo-Yo 2, 2 to 10 minutes. The energy systems, PCR, the glycolytic early, and glycolytic alone late. The Yo-Yo 1 is aerobic dominant, and the Yo-Yo 2 is glycolytic PCR dominant. Lactate, 9 to 15 RSI, 8 to 12 Yo-Yo 1, and 12 to 15 Yo-Yo 2. VO2 max correlation, the RSI is low to moderate, Yo-Yo 1 is high, and Yo-Yo 2 is moderate. Reliability, 3 to 7% RSI, the 1 5 to 8%, and the Yo-Yo 2 it's basically 6 to 10. What is the kind of fatigue? On the RSI is peripheral and central. On the Yo-Yo 1 is cardiovascular and aerobic limit, and the Yo-Yo 2, the fatigue type is metabolic and ionic accumulation. What's the correlation on the match? The sprintability is from 7 to 0.71 to 0.77. The Yo-Yo 1 high intensity running is around 0.81, and on the Yo-Yo 2 the peak 5 minute intensity is around 0.72. Test selection and decision framework. The sprint repeatability needs to assess ability to reproduce maximal sprint efforts under fatigue with short recovery, the RSI test. If you need the aerobic capacity, you need global measurement of intermittent endurance and VO2 max estimations for general fitness, Yo-Yo 1. If you are looking for elite anaerobic players, you need to discriminate elite level or assess severe intermittent recovery with high anaerobic load. You use the Yo-Yo 2. What's the positional guide for wide pressers, RSI, and Yo-Yo 2? Midfield engines, Yo-Yo 1, and defenders, RSI or Yo-Yo 2, depending on the role. The training phase that you can use on the GPP, Yo-Yo 1, because you establish the baseline. For the specific preparation, RSI or Yo-Yo 2. And the tapering season is light monitoring or submax. What are the practical constraints? Time and group. Yo-Yo allows mass testing. Another constraint is the space and equip. The RSI needs timing gates plus 30 meters plus. And the specificity shows change of direction format relevant to the sport. The practical applications for strength and conditioning and monitoring profiling. The RSI program maximal sprints, 10 seconds with 60 recovery to target a specific RSI. The HIT programming, you use the percentage of velocity of the Yo-Yo 1 to prescribe intensities for 15 to 15 seconds, 30 to 15. You have the specificity on implement change of direction and RSI on the RSI protocols. You have a speed power pairing. You integrate plyometrics or contrast training with sprint work to enhance neuromuscular efficiency. The monitoring and load management. Testing frequency, conduct assessments every 4 to 6 weeks to track adaptation without inducing fatigue. Consider changes above 5 to 10% as meaningful physiological adaptation and disregard noise. What are the trend analysis? Track longitudinal trends in fatigue index and sprint decrements alongside match data. And you can integrate the GPS. Integrating profile and decision making on this is better to have an holistic profiling, combining the RSI and the Yo-Yo scores with force velocity profiles, jump test, and maximal sprint speed for complete physical audit. You proactively reduce training volume or intensity when monitoring scores dip significantly below the smallest worthwhile change. And you build a solid aerobic base with Yo-Yo 1 focus training and then transition to the RSI or Yo-Yo 2 specificity during pre-competition phases. And this helps you out on the data visualization, utilizing the dashboards with traffic light systems like red, amber, green, or red, yellow, green, to communicate readiness and fatigue status to the coaching staff. Here are the takeaways for practitioners. This is a complementary spectrum because all of them cover the distinct physiological ends of the intermittent spectrum, offering a complete profiling when used together. This shows a strong correlation with high intensity running, repeat sprint sequences, and peak game intensity windows. Also helps you out on actionable monitoring, like tracking smallest worthwhile changes and integrate with the GPS and RPE data for holistic load management and decisions. You have energy system clarity because the PCR drives sprint quality, aerobic system powers recovery, and glycolytic capacity supports severe work tolerance. Helps you out on the strategic selection using the decision framework to align test choice specifically with sport demands, player position, and training phases. Structure progression, build aerobic base with the Yo-Yo 1, transition to the RSI and Yo-Yo 2 specificity, maintaining and monitoring through the competitive season. And here are the references that I use for this presentation. Well, thank you very much.